Dear colleagues, I would like to present the report Software Implementation of the Multivariate Method for the Hodgkin-Huxley Model. Despite significant achievements in the field of mathematical modeling of medical and biological processes, a number of problems arise when using the approach to studying the electrical activity of cells. We consider Hodgkin-Huxley model of biological neurons that describes in detail the initiation temporal response of action potentials in biological cells, illustration of the neuronal biological membrane. The neuron itself as well as the membrane are surrounded by the extracellular medium, a global electrolyte that contains various ions species. The membrane also encloses the intracellular medium that is similar to the extracellular space. The membrane forms a capacitor due to the difference in ionic concentrations between the intracellular and extracellular space. Various elements on the membrane surface are acting in parallel, and the equivalent circuit of the membrane is depicted on the right. For cells with potassium, sodium, and chlorine channels, the total current through the membrane will be calculated according to the last formula in the slide. The Hodgkin-Huxley model, or conductance-based model, is a mathematical model that describes how action potentials in neurons are initiated and propagated. It's a set of non-linear differential equations that approximate the electrical characteristics of excitable cells such as neurons and muscle cells. It's a continuous time dynamical system. Different types of neural excitability. When an increasing voltage is applied, the excitable membranes can transit from rest state to continuous firing in following ways. In type 1, the frequency of action potential increases continuously from the start of the stimulus, thus it accepts the full range of frequencies of the stimulus. In type 2 excitable neurons, there is sudden jump of action potential once the current threshold is reached. In type 3, excitable is the production of a single action potential in response to constant over the threshold stimulus. The final typical Hodgkin-Huxley model of ionic conductivity of cell membranes is shown in the slide. Obtaining results regarding the qualitative characteristics of cells in analytical form based on the system of the Hodgkin-Huxley type doesn't seem possible due to the complex of non-linearities of the equations. The model is a system of non-linear differential equations. Application of differential equations for mathematical modeling doesn't mean obtaining analytical representation for their solutions. Moreover, these formulas doesn't exist in most cases. A formula for clear or approximate analytical solution is very often so complex that nothing can be said of nature of the solution. This is why in practice graphs or solutions are generated without getting the solution in the form of formulas first. Previous work on the classification of excitability used bifurcation theory. Tonliner used simple phenomenologistic Skyping neuron model to derive a criteria for the determination of neural excitability based on the after potential following a spike. Typical methods of qualitative analysis aren't capable to study this excitability model. The basic idea of the method is to use the Monte Carlo method to gather learning tuplets that are further used in data mining algorithm. In the work, we offer a fundamentally different approach to the qualitative analysis of the Hodgkin-Huxley system, which uses a multivariate method of simulation modeling with the subsequent application of data meaning algorithm. Basic idea of multivariate method for qualitative analysis. We generate initial values and rate constants randomly that they belong to the range. For each of parameters, we integrate system and obtain corresponding trajectories. Decision tree induction algorithm will be applied to the results obtained in the order to discover some knowledge structure for trajectory classification and prediction. The algorithm of data meaning technology, decision tree induction, sequential coverage method is applied in order to obtain certain knowledge structures for decision making. The approach includes the 5 steps. In the first, we determine the trajectory classes of the system. Figures show typical representation of 3 classes of trajectories, types of neuron excitability when the applied current increases. In the second step, we assume that the initial values and velocity parameters are evenly distributed at intervals. Each column corresponds to a set of values of one parameter, either the initial value or the speed parameter. Each line is a set of initial values and rate constants for one running the method based on the model. In the third step, each set of initial values and rate parameters generated, output trajectories are classified on the basis of criteria proposed in the first step. Next is the method assumes that for the system trajectory shape, correlation between initial values and rate constants is more important than their absolute values. So the metric containing information in the categorized coded form on the relationship between initial values and rate parameters generated in the step 2 is constructed. In general, the method combines the Monte Carlo approach for forming training sets and data meaning classification algorithm, the sequential coverage method with the generation of classification rules, and the decision tree induction method. A software environment for the study of electrophysiological processes based on the Hodgkin-Huxley system has been developed in the form of the library of Java classes. To implement the method, a package of Java classes has been developed. The package includes classes data manager, multivariate method, etc. Next, the Hodgkin-Huxley system integration class applet is launched. At the same time, the expert chooses the shape of the obtained trajectory. After that, the parameter interpretation matrix generation step is launched. At any moment, the user can run the decision tree inclusion algorithm. The build decision tree for N17 is shown in the slide. The proposed multivariate method of qualitative analysis of model of electrophysiological processes is an approach that allows solving the problems of classification of cell excitability which can't be solved by other traditional methods, such as stability theory or limit cycle. In the future, such a software environment should be focused on the construction of and research of electrophysiological models in all aspects of physical impact on biological tissue. Thank you for your attention.